right, in this video we're going to go through how to solve some exponential equations using logs. So back when we had some of the easier ones, we used this thing called method of common bases, where we want to change 4 into 2 squared and 8 into 2 cubed so that we get the base the same, and then we distribute this exponent, so we get 2 to the power of 2x equals 2 to the power of 3. And now these bases are sort of don't matter. We can get rid of them and say 2x must be equal to 3. So I divide by 2. So x must be equal to 3 halves, or 1.5. Now we can get the same thing using logs, and this is really where the definition of logs comes from. Logarithms are exponents in their most basic form. But we use them when we get equations that we can't do in our head, or if we can't even figure out if it's a fraction. So logarithms mostly are irrational numbers, like square roots and pi. They go on, they're decimals that go on and on and on. So the log approach would say, using our third logarithm law here, that says if we have this part on the left, we can move the x into the front. That's what's going on. So our equation doesn't look like that yet, but we've got this a to the x right now is 4 to the x. So if we take the log of both sides, let me rewrite it like this, log, and I put the 4 to the x inside a log, I just have to take log of the other side, and now I haven't broken any rules of equality. Whatever you do to one side, you do to the other. And I'm just going to use, this says log base b, I'm just going to use common log with base 10, because that's what my calculator uses. So now that I've done that, I can move this x in the front and say x times log of 4 equals log of 8. And now log of 4 is just some number. It's a decimal. And if we're multiplying by that, to undo that number, we divide by log of 4, and that will cancel it out. So then we just do that on the other side, and we get x equals log 8 over log 4, and now I can go to my calculator, type in log 8 divided by log 4, and see that it's exactly 1.5, just like what we got before. Pretty amazing. This will help us solve much harder equations where we can't come up with the same base. So now we have 2 ways to solve an equation like this. The next examples are where you cannot find a common base. 5 and 18, you can't write 18 as 5 to the something, like 5 squared, no. 5 to the first, no. 5 to the minus 1, no. There's no power I can raise 5 to get 18. So that's why we have to use logarithms. So here we go. We just write log, oops, that should be 5 to the power of x. My eraser, so 5 to the power of x. And then log of 18. And now that reminds me, I can move this power here. Whoops, that should be an x. Can move that power here. And I get x log 5 equals log 18. And now I can divide both sides by log 5. Sometimes students get sick of writing log all over the place. So I can show you maybe on the next one how we can kind of eliminate some of that. So then I go to my calculator, and I'm going to get one of those non-repeating decimals. And so now I'm going to ask you to round 2 decimal places. So 1.79, the next digit's a 5, so we have to round up to 1.8, and that's only 1 decimal. So that 5 bumps the 9 up to a 0, and bumps the 7 up to an 8. So I need to write that 0 in this case. That tells me that I have rounded. So I should use the approximate symbol. And notice if I go back and check my answer, 5 to the 1.8 does not equal exactly 18. 5 to the power of 1.8, right? It's a little bit too high. That's because I rounded up. I have to do 5 to the power of 1.795 and give all those decimals for the calculator to recognize that I'm going all the way back to 18. Okay, second one, if you've got a number in front, we have to get rid of that first. And so if it's being multiplied, we undo it with division. So then we have 4 to the x equals 100 divided by 10 is 10. And now we're back to how we had before. And maybe you'll realize, so I don't have to write log, 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 log. What's going to happen? This x is going to come in the front, and then I'm going to have log 4, and then log 10. And notice I don't have parentheses. You'll see this a lot, maybe on worksheets or other classes where we get lazy and we don't use the parentheses. So then now I'm just going to divide the log 4 on both sides, and I get this, log 10 over log 4. Now I can go to my calculator. Log 10, close the parentheses, log 4, and I get, let's say, 1.66 because the next digit is 0. So x is approximately 1.66. Okay, last one. We've got some more stuff going inside the exponent there. So when I take log of both sides, let's just write it out the long way for this one, just so you can see. It would look like this with parentheses. Now this, whatever is in this power, I can move into the front. But when I do that, if it's a binomial or trinomial or whatever, we should put parentheses around it because that whole thing is being multiplied now by log of 3. And I still have log 200 on the other side. So now, again, I'm just going to divide by log 3 just like we did before, but there's an extra step at the end. This part cancels out, but I still have x plus 7. Now I'm going to go to my calculator and say log 200 divided by log 3. Keep that number there. Don't round it yet, because what am I going to do? I've got x plus 7 over here equals that number that I just got, 4.82. So I'm just going to write down approximately. So now I'm going to do the last step, subtract 7. So with my calculator still here, I'm just going to type the minus button. A and S means previous answer, minus 7, and I get negative 2.177. 2 decimal places would be 2.18 because the 7 is going to bump that up. So negative 2.18. And yes, you can get negative answers here. Let's plug that back in. 3 to the power of negative 2.18 plus 7 should be close to 100, but not exactly. So 3 to the power of negative 2.18 plus 7. I'm going to have to do parentheses if I do some operations within the power. And that should be about 200, and it is. Okay. Now, I don't know why I have this extra slide in here. Now I'll do a word problem and we'll be done with this lesson. A stock's been declining, so that's a word for decay. A pace of 5%, so that's 0.05. The stock started at 22.50. That's going to be our initial amount. Determine the number of weeks it will take for the price to reach 10. We did problems like this before where we set up the equation and we just guess and check, or we use a table on the calculator. But now we can do this algebraically. So remember, this formula is the initial amount 1 minus the rate, and that will equal the future amount. So I know it's minus because it says declining. So now to solve this equation, I could first do 1 minus 0.05, which is 0.95 to the t. Or you could write x, doesn't matter. But if I've got this 2250 over there, I need to divide. So 0.95 to the t equals 10 divided by 22.50. I don't really need the 0. That's 0.4 exactly. So if you write 0.4, this is wrong. We need all of those 4s. Okay, the next thing, and actually I'm going to say math fraction and say this is actually 4 over 9 so that I use the full number. Because now what are we going to do? We're going to take the log of both sides, which is going to move the t in the front. T times log. I'm going to use the x this time because we've got this decimal here. And then I have to take log of 0.4 repeating, which was 4 over 9. Then I'm going to divide both sides by log of 0.95 to cancel that out. And this is going to be my answer. So we get this exactly well. And really, we're going to have to round this anyway. So it said round your answer to the nearest weak. So that means whole number. So let's do log of 4 over 9 and then divided by log of 0.95. 15.8. So to the nearest week, that's about 16 weeks. But I think more realistically, just to test if you're rounding right, and if you're using, like if you use 0.4 instead of 4/9, watch what would have happened. Log of 0.4 divided by log of 0.95. Watch how much different it is. 17.8. We would have rounded that up to 18. That's a difference of 2 weeks. Like, that's too much. We rounded way too soon if we used 0.4. We don't want to do that. So 15.8 weeks, or we could say about 16, depending on where I tell you in the problem to round. Okay, thanks for watching. That's it.